Here are the practice problems for integration by substitution. Your certified problems will be in the same order. So I just want to get these done so you'll have examples to go by. X minus 2 to the fourth power dx. And it says use substitution, okay? And so all of these are substitution problems. And so that means you're going to need u and du. All right, so we always let u be the inside. So u is x minus 2. And the derivative of x minus 2 is just 1 dx. So when we rewrite this in terms of u, that's going to be u to the 4th. And the only thing left over is dx. Okay, we use the derivative for that. What is dx? Well, dx is du. So now we're just at rule 2, add 1 and divide. So that's going to be u to the 5th over 5 plus c. And then when we put it back in terms of x minus 2 to the 5th over 5 plus c. And some people write it like this: 1/5 times x minus 2 to the 5th plus c. Either of those is fine. I don't know, somehow this got away from me. So, okay. All right, so looking at the next problems. Okay, so question number 2 is the integral of 1 over x plus 7. Some of these are simpler, and that makes them harder, but we started off with some pretty good examples. Remember, step number 1 says move the denominators up. And so when I rewrite that, it's the integral of 1 times x plus 7 to the negative 1, because that's understood to be to the first power. And so my u is x plus 7, and my du is 1 dx. And so when I rewrite this in terms of u, that's just u to the negative 1, and dx is just du. And so when I go to apply my rules from the last section, when I add 1, what happens? I get 0, so that means we're using rule 3. That's going to be the ln of the absolute value of u plus c. So my antiderivative with respect to x is the ln of x plus 7. Don't forget you need the keypad for the ln and the absolute value and your plus c. Okay, all right, so let's look and see. Okay, let's look at this one. It's very similar, but just they start to get a little bit more interesting. Question number 3 is the integral of negative 10 over 5x minus 6 dx. Okay, so they tell us it's substitution, right? And so I'm going to need to rewrite it, bringing my denominator up. And remember, if there's no, we have to bring the whole denominator up, so it's understood to be to the first power. Okay. All right, so what is my u? It's the inside. It's 5x minus 6, and then the derivative is 5 dx, because my function is with respect to x. So remember, when I rewrite this in terms of u, I'm going to bring my negative 10 over like that, and my u to the negative 1. And then the only thing I have left over here is dx that hasn't been brought over. So I'll look at my derivative, and if I divide both sides by 5, I get dx is what? Du over 5. Okay, so if you want, you can call that negative 2u to the negative 1 du. And then when I use my rule to add 1 to the exponent, it becomes 0. So this one is also the ln of the absolute value of u plus c. So when I put it back in terms of x, and my u is 5x minus 6 plus c. Okay. And so, I mean, these are just the same things over and over. Question number 3 and question number 4 are very similar. So I'm going to skip question number 4 and let's look at question number 5. It looks kind of interesting. The integral of 25x to the 4th plus 15 over x to the 5th plus 3x minus 9 dx. Okay. All right. So the first thing I have to do is move any quantities up. Let's see if I can get that more focused. Okay, so I'm going to rewrite this. So that is the integral of 25x to the 4th plus 15 times x to the 5th plus 3x minus 9 dx. And when I bring that denominator up, that becomes to the -1 power. Okay, so now I have to pick my u and find my du. All right, so I could pick u to be 25x to the 4th, or I could pick u to be x to the 5th. This one is inside the -1 exponent, but let's say there was an exponent. If you're going to pick one, you want to let u always be the one with the higher power because the derivative will be less. Okay, so we're going to pick u to be x to the 5th plus 3x minus 9. Okay, and my derivative is 5x to the 4th plus 3 dx. Okay, so here we go. This one's a little different. Okay, so, now remember, I can't bring any x's over. I can only bring u's over. Okay, so if I could bring this over, this right here is u to the -1. And I have 25x to the 4th plus 15 dx. Okay. But look, I have 5x to the 4th plus 3 dx. Okay. I have to make these match. Okay. I mean, what would you multiply 5 by to get 25, right? If you multiply this whole thing by 5, you get this right here. So let's just factor out a 5 there. And let's just say, okay, I already brought my u to the -1 over. Okay. All right, and so now I'm going to bring that constant 5 over that I factored out. Okay, so what do I need? 5x to the 4th plus 3 dx. And look, I have them, 5x to the 4th plus 3 dx, and that's just du. So in order to make a match, I had to just factor out the 5 so I can have that there. Okay. All right, so when I add 1, what happens? It gets 0, so that's just going to be 5 times the ln of the absolute value of u plus c. So when I put it back in terms of x, the absolute value of u, which is x to the 5th plus 3x minus 9 plus c. Those are a little trickier. You have to make a match here. So it always happens by a constant. So I just took out a 5. And there, I said I have these two match. I'm going to bring over my 5. And I got it. Okay. So yeah, that's a little trickier. And because of that, they gave us another one to do that I will do. So let's try number 6. Okay. So this is the integral of -30x cubed plus 50 over 3x to the 4th minus 20x plus 8. Okay. So I know I have to move my denominator up. So I'm going to rewrite this thing. Okay, so negative 30x cubed plus 50 is already up. And I bring this up. Remember, it's to the first power. And I'm going to make it to the negative 1 power dx. So all my x's are here. I've got to make it in terms of u. So I've got to use my u and my du in order to rewrite. So remember, if you have to pick your u's, you always go for the higher power. There's x to the fourth and x cubed. We're going to let u be the 3x to the fourth minus 20x plus 8. And then what is the derivative here? 12x cubed minus 20. I think this one's going to, and dx. This one's going to be a little bit trickier. Okay. All right. So let's do this. Let's bring over u to the negative 1. I think I'm going to need a little bit more space. So let's go here. And this is going to be u to the negative 1. Okay. But now I've got to use my derivative to get negative 30x cubed plus 50 dx. Okay. All right, so I've got to make these guys match by a constant. So what could you factor out up the top? Maybe a negative 10 and get 3x cubed minus 5, right? And what could you factor? The variables match, but what could we factor out of the bottom? And there it is, 3x cubed minus 5 dx. Okay. All right. So let's look. What we have to do is I have u to the negative 1. And look, I have a negative 10 on top and a 4 on the bottom, okay? So when I bring my negative 10 on top, my 4 on the bottom, and my du is right. And so that's gonna, those are gonna divide out, and I bring my constants on top and bottom, du. Okay, all right, so here we go. When I add 1, what happens? I get 0 divided by 0, so that won't work. This tells me that is negative 10 over 4. You don't have to reduce. ln of the absolute value of u plus c. So negative 10, that's f of u. ln and my u is 3x to the fourth minus 20x plus 8. Okay, all right. So remember when I told you that we were undoing the chain rule? Okay, and u substitution is u substitution, and it works the way it works. But sometimes it's easier for me in a situation like this to work it in a different way. And I'm going to show you. And this is kind of like the cheating way to do it. X to the fourth minus 20x plus 8 to the negative 1. Okay. All right. So look, what is my u? And what is my derivative of u? Okay. All right. So if when you did the chain rule, you had to multiply by the derivative of u, what we're really doing is dividing by the derivative of u. Okay. And so what you want to do is you want to make these match. Sometimes it's easier to see it when you put them on top of each other. So my greatest common factor on the bottom is 4. And my greatest common factor on top is -10. 3x cubed minus 5. And then they cancel, and you can see better where you have your -10 on the top and your 4 on the bottom and your u to the -1. However you want to do it. Okay, but the answer is still -10 fourths ln of 3x to the 4th minus 20x plus 8 plus c. Okay, all right, now we're gonna go on to the next one. Those are the hardest ones, I think, the ones where you have to make a match. Okay, so then the next one I have is e to the 3x to the 7th minus 9, and then times 21x to the 6th. Okay, so remember when you pick u is always the inside, but since there is no inside, we're going to let u be the exponent on e. And what's the derivative of u? 21x to the 6 dx. So when I rewrite this in terms of u, it's e to the u, and I need 21x to the 6 dx. Well, that's just du. So I have the antiderivative of e to the u, and it feels like you're not doing anything, but that's like e to the kx. It's just e to the kx divided by 1, but it's e to the 1u divided by 1. So that's just e to the u plus c. So the antiderivative with respect to x is e to the 3x to the 7 minus 9 plus c. Okay. So, all right, so here's another. The integral of 3x squared plus 9x plus 1 9x plus 1 times 6x plus 9 dx. Okay, and it's substitution, and it's telling me, sorry, that, all right, so I have to have a u. So which one do I pick? Neither is to a power other than 1. So do you remember which one you picked? You picked the one, it's not necessarily the first one, the one, here's 3x squared, here's 6x, the one with the higher power. And so the derivative of u is 6x plus 1 dx. And so when I write this as u to the first, right, because that's the understood one, 6x plus 9 dx, oops, it's just du. So people get stumped here a lot because they go, I don't know how to integrate u. But remember that's u to the first, so you just add 1 to it, and you get u squared over 2 plus c. So your antiderivative with respect to x is plus c. Okay, and you see that these pretty much all work the same. Let's make sure we get some fractions. And then there's one that's a little bit, 6 times negative 5t minus 7 to the negative 4 dt. Okay, so it says use substitution, so we always let u be the inside, and the derivative of u is -5. Okay, all right, so that's going to be the integral of u to the -4th, right? And I bring my constant term over, and what's left over? dt. Well, what is dt? I divide both sides by -5, so dt is du over -5. So it's du over -5. So now I just apply my rule. When I add 1, I'm going to put my 6 and my -5. I'm going to bring them over. So u to the -3, and I divide by -3. I'm going to put that in parentheses and just be really careful because it looks like subtraction if you don't. And so when I write my answer in terms of t, it's 6 times -5t minus 7 to the -3 over -5 times -3 is positive 15. Okay. All right, so here we get some square roots and a little bit of interesting stuff. Or we're getting there. The integral of 6 over the cubed root of 7y minus 4. dy. Okay. All right. Well, it says substitution. These are all substitution. But the first thing I have to do is rewrite this as 7y minus 4. And it's the cubed root on the bottom. So that means it's 1/3 on the bottom. So if I bring it up, it's the negative 1/3. That's a y. Sorry. Okay. All right. So I always let u be the inside. And the derivative of u is 7 dy. Okay, so when I rewrite this in terms of u, I'm going to make that u to the negative 1/3, bring over my constant term 6, and I just need dy. Okay, so I use my derivative. I have 7 dy, but if I divide both sides by 7, I get du over 7 is dy. So dy is just du over 7. And I'm ready to go. So I'm going to bring my 6 over 7 and u. I'm going to add 1 to my exponent. It's 2/3. And remember, I'm going to divide by 2/3, but that gets kind of ugly. So instead of dividing by 2/3, I'm going to multiply by the reciprocal, which is what? 3/2 plus c. So my antiderivative with respect to y is 6 times 3 is 18u, which is 7y minus 4, to the 2/3 over 14 plus c. And you could say 2 goes into 6. 3 times 3 is 9 over 7. It doesn't matter if you reduce or not. I just say leave it because you could make rounding errors. Okay? 11, and then this is the integral of -5y, whoops, you can't see, times e to the 3y squared, dy. Okay, so we always pick u to be the inside, but since there's no inside, we're going to let u be the exponent on e. So u is 3y squared, and the derivative of u is 6y dy. Okay, so remember when you have e to a power, instead of u to a power, this is e to the u, okay? I'm going to bring over my constant term, -5. Remember, I can't bring over that y, so I can't mix up my variables. This is all y's, this is all u's. So I need y dy to come over. Well, what is y dy? I divide both sides by 6, and there it is. du over 6 is y dy. So it's du over 6. So when I integrate e to a power, e to the u, it's just -5 over 6. E to the u plus c, and I put it back in terms of y. -5e to the 3y squared all over 6. It doesn't matter how you want to do it. Here you go. Okay, so don't be scared of the e's. All right, this one might be a little scary. All right, question number 11. No, 12. Okay, all right, so the integral of -4e to the -3y times 7 minus 5e to the -3y, all of that cubed dy, and that looks like a really ugly problem, but we should go back to my original steps. So there are no denominators to move up, okay? And it says pick U, but you see you have E's and you have everything, but always pick U to be the inside of a quantity if there is one, okay? So you're not even worried about the exponent on E. You're going to let U be the inside. So we have, I'm going to rewrite this, -4 e to the -3y times 7 minus 5 e to the -3y cubed dy. And we're going to rewrite this whole thing in terms of U. Okay, so U is the inside, 7 minus 5 e to the -3y. All right, and this is what people miss, is the derivative of U. So remember, the derivative of 7 is 0, but it's -5 e to the -3y. We don't divide by -3 because it's the derivative, so we multiply by -3. So the derivative is 15e to the -3y dy. Okay, so we're going to use these things. So U cubed goes over. Okay, I'm going to bring over my constant, -4. All right, and I have e to the -3y dy to bring over. So I can get that just by dividing both sides by 15. Okay, so it's du over 15. Okay, so I bring my constant, -4 over 15, add 1 to my exponent, divided by 4 plus c. And so my antiderivative with respect to y, you don't have to reduce, -4 times 7 minus 5 e to the -3y to the 4th over 60 plus c, or you could have reduced the 4's and just called it -7 minus 5 e to the -3y to the 4th over 15. It doesn't matter, either one of those. You'll see this again. Okay. Last couple of problems. The integral of -6t to the 4th times the square root of 4t to the 5th plus 5. Okay, so the first thing we're going to do is rewrite that square root is what? I'm not bringing it up, so it's not going to be negative. It's the square root is 1/2. And this side is going to be all u's, okay? T's and u's, don't mix them up. All right, so my u is 4t to the 5th plus 5, and the derivative of u is 20t to the 4th dt. Okay, all right, so let's get started. Let's bring my u to the 1/2 over, bring over my -6, get my constants out of the way, and what's left over to substitute for? T to the 4th dt, so I just divide both sides by 20. So du over 20 is t to the 4th dt, so du over 20. Okay, same thing over and over and over. So when I integrate, I'm going to bring my -6 over 20. I'm going to add 1 and get 3/2. So it's u to the 3/2. And instead of dividing by 3/2, I'm going to multiply by what? 2/3. Got it scrunched up. And you can simplify if you want, but I would just write that as -12 times 4t to the 5th plus 5 to the 3/2 all over 60. Will you go outside and tell her I'll call right back. Okay. All right. So, and if you wanted to reduce it, you could, 3 goes into 6 2 times 4, 5, you know, however you do it. And then 14 is pretty much just like that, 13 and 14. I'm gonna just let y'all do that. And I'm gonna look at number 15. Okay, let's do number 15. And this is the last one. So it's the integral of 6e to the 5t and e to the 5t plus 6 dt. Okay, well, I'm going to rewrite this by moving that denominator up to the -1. And so my inside will be, e to the 5t plus 6. And what's the derivative of u? 5e to the 5t dt. So I'm going to bring my 6 over and my u to the -1 over. And I need e to the 5t dt. So I just divide both sides by 5. And I get du over 5. I'm going to integrate, add 1. I get 0 divided by 0. 6/5 times the ln of u plus c. Shortcuts. My kids are trying to call me because it's Mother's Day, and I'm going to go talk to them. You've got 6.1 and 6.2. You're all done with all the information for test 1, and I hope this helps, and you just have to keep me posted and let me know what you need me to do. But I will see y'all tomorrow morning, or by the time you see this, I'll probably already see me. Okay. All right.